We are still looking to improve the mesh visuals, and this lesson we are going to discuss the normals. First, we'll review some important concepts. First, vector with location. It's very important just to remember vectors have direction and value, but no specific location. So when we say the word vector, this is mean we should always remember vector mean there is direction. There is direction and there is value, but no positions. Location has position, has coordination point only. So if I say location, this is only one point in the whole system or in the whole word space. It have this point. If I say point 030, it is only this point 030. However, if we say vector 030, this is direction. You can put it here, you can put it here, you can put it here. If it starts from B0, 030 will match with point 1. But if you put vector in point 1 and it is have value 030, then it will become go up 3, so it will become 060, the end of the direction. But it is direction. It's not showing specific location. It's telling you go from this direction. This is very important to understand this concept. So let's say we have point 1, 030. If we go in unity in the word space, we will go in from 00, we'll go direction 0, 3, 0. It's only this location. There is no other location for that. B2, 300. Again, we'll go in x-axis 3 and there is 00 in the direction. So point 1 is clear what is it, and point 2 it's clear where its location. Now if I say I want the vector from B1 to B2, this is mean if I am standing B1, I want to go in direction of B2, where I will go, what is the direction and how much the value. Now we can get it by finding vector. Now the vector here, it will be the equation vector equal B2 minus B1, that's the target point minus the reference point in general. So in this case the vector will be, we'll take B2x minus B1x, B2y minus B1y, and B2z minus B1z. So it will become 3 minus 0, 3, 0 minus 3 minus 3, 0 minus 0, 0. So vector from B1 to B2, 3 minus 3, 0. Now it's very important also to understand the reverse way it is not matching. I mean B vector from B1 to B2 is not equal B2 to B1. Well, let's see. Now let's calculate the vector from B2 to B1. This means if I am standing point B2, I want to go to B1, I will go in this direction. So let's calculate it again. Now the target will be B1 and the original point B2 because I'm standing B2. So I will start by calculate the target. 0 minus 3 minus 3, 3 minus 0, 3, and 0 minus 0, 0. So the vector will be minus 3, 3. So you can see it is the, I have here minus 3, you have there positive 3, minus 3, positive 3. So it is the direction reversed. You can see here, this is, if we say this is the vector from B2 to B1, I can use the vector from here, so it can show me direction and value from here. This is the vector. I can even use it from here. This is the vector. If I say 0, 3, I'm going now from B2 to B1, so this is will become this case, which is minus 3, 3, 0. So if I go minus 3, 3, 0, this is the direction. So remember, vector could be used here, could be used here, could be used here. It is just showing direction and value. It's showing you where to go. But B1 or B2, in general location, it's clear, fixed value. This is B1, we understand this is the point. Second, we need to understand or to discuss the cross product. Cross product in general, if I multiply vector with vector, the result of the multiplication, it will be perpendicular vector on the level that contain both vectors. So if I have vector from B2 to B0 and vector from B1 to B0, I multiply both of them. The result one vector will be vertical over the plane that containing both of them, meaning in this case it will be a vector perpendicular to the triangle. In vectors, we have a process we call normalizing the vector. Normalizing the vector, this is meant to make the values of the vector from 0 to 1. And this is easy to be done by calculating or by dividing the component of the vector in the value of the vector. And we'll see how to do it mathematically later. So, the question now again, what is the normal vector? We'll go for Blender 3D software and check the normal from there to make things more clear. This is Blender 3D and we have simple shape here, which is a cube. Now if we select the cube and we go for edit mode, here you will find the settings. This cube, each faces of the cube, there is one line is going outside. This line, I will do it in such a way it will be showing you the normal vector direction exactly. So this is called the normal vector for the surface. Since the cube have 6 surfaces, 6 faces, so we have 6 normal faces for the cube. One normal here, one normal here, one normal here. Now you can see this vector. It is coming perpendicular in the face. This is number one, we need to notice it. Another point, each faces will get its own vector. Now, why we do this? Why we need this vector? Now, let's say this is the light in our scene, and this is our game object in the scene. Now, we attach material for the scene. So we know, for example, this is coming green color. Now we need to calculate the light and the shadow. To calculate the light and the shadow, to make the things more realistic, in the shader it will be start calculating by calculating the light source and apply some rays of the light to the surface of our material. So it will making a ray direct to the surface. Now this ray should reflect. To reflect, we need to understand the perpendicular vector because we'll use it in our calculation at the shader. And based on that, it will start calculate the light, it will calculate the shadow based on the distance between the reflection, and of course there is more variables in this calculation, not only that much simple. Especially in Unity we are using if you use the standard shader, it will be BBR module, which is going for more in the calculation like roughness, like the metallic characteristic, not just only the color. But the general idea, the normal vector is used in the light calculation. Now, this vector could be also for each vertices. So let's take overlay here in Blender 3D and we go down. In Blender 3D it can calculate also each vertices the perpendicular line. So you can see here in each vertices there is direction for the vector, and if we go again overlay and we show exactly, now you can see this is the vector normal for the vertices. Now maybe you will ask, okay, if this is the normal for the vertices, why then the surface is vertical and this is coming with little slope? It's not matching in the direction. That's because the surface vector normal, it will be the average for the 4 vertices. And the average for it, you can see the direction of this vector and the direction of this vector, have opposite direction. So if this one in this direction, this is having this direction in the opposite way. Also this vector have the opposite one the other way. So the average of these vectors, it will be perpendicular here. That's number one comment. Number two comment, why it's coming slope first of all, why the vertices itself not vertical. That's because this vertices is shared between this surface, between this surface, between this surface. So if the vertices have more than attached surfaces to it, in that cases we'll calculate the normal for this surface, normal for this surface, normal for this surface at that point, and we will take the average of these three surfaces together. So you will get the result, this normal vector, which is the average of the three surfaces. So we can calculate the normal for the face. So in that case, all the points in the face, it will be the same normal, or it will be go for each vertices. In Unity, it will be calculated per vertices, not per the face. So it will be each vertices have its own normal, and any points in the surface, it will take like percentage between this point and this point. And remember, in Unity, it will be triangulated shape, not quad shape. The balance will be continued at part 2.